Okay, in this section we're going to talk about adding and subtracting rational expressions and common denominators. So the first thing we're going to need to do is be able to figure out common denominators, least common multiples. So let's go back to arithmetic again and sort of remind ourselves how common denominators work with numbers. So let's look at, let's say we have 6, say 15ths, which isn't in the lowest terms, but that's fine. And let's say 3/8. And let's go with one more term and go with 5/14. Okay, so I have three fractions here, and I want to find a common denominator. So finding a common denominator. So the idea is each of these fractions represents some whole thing divided up into parts, and then I have some of those parts. So this first one has 15 equal parts, and we're interested in 6 of them. The second one has 8 equal parts, and we're interested in 3 of them. The last one has 14 equal parts, and we're interested in 5 of them. Okay, so I've broken some whole thing up. Think of it as a pie or a pizza or a cake or something, and I've got 15 equal pieces, 8 equal pieces, 14 equal pieces. And what we want to do is we break it up into 15 equal pieces, and then we're going to break it up into further pieces so that I can have some number of those pieces be eighths, and then break it up further again so that I have 14ths. So I need to find some small piece size so that I can also put them together and get eighths, 14ths, and 15ths. I'll draw a picture with smaller numbers after when we get through this. But the first thing we do is we factor the denominator. So I have a 3 times a 5 for the first one. I've got a 2 times a 2 times a 2 for the second one, and I've got a 2 times a 7 for the last one, right? Okay. And we want to find a common denominator, and the least common multiple is the one that we're going to use. So the least common multiple will be the smallest denominator you can have that all of these things will go evenly into it. So I want a number that 15 divides into evenly, 8 divides into evenly, and 14 divides into evenly. So I need a 3 and a 5 in the prime factorization. I also need 3 2's in the prime factorization so that 8 goes into it. The 3 and the 5 would cause the 15 to go into it. The 2 and a 7 in it would cause the 14 to go into it evenly. So the LCM of these three things is going to equal, well, I need 3 2's, so I'll write those down first. I'll write down 2 times 2 times 2. I'm going to start with the smallest primes. So I need at least that many 2's so that it will be divisible by 8. I need a 3 and a 5 so that it's divisible by 15. I need a 2 and a 7 so that it's divisible by 14. I already have a 2. In fact, I have 3 of them. I have extra 2's, but I just need 1 2 and 1 7 so that this is divisible by 14. So I take those 3 2's, a 3, a 5, and a 7, and I get the least common multiple of these three things. Okay, so that's going to be 8 times 3 times, say 21, so this is 24 times 21. Which is going to be some sort of large number. Uh, 504. So my least common multiple will be 504. And that's going to be my smallest common denominator. So we can do this with rational expressions too, but let me draw that picture that I was talking about before. So let's say I have 1/2, I have 1/3, and I have 1/4, and I wanted to find the least common denominator. So I'm going to draw a circle here first. and we'll take green. So if I split this circle in half so that I have the halves, okay, so I've got 2 pieces that are equal for the halves. Let's pick a different color. Let's go blue. We're going to do that for the thirds. So for thirds, I start out the same, but then I go off this way and I go off this way. It's kind of like a peace sign sort of deal. But here's 1/3. This thing together is 1/3. This is 1/3. We can sort of see that this is 1/2 and this is 1/2 there. And then if I want fourths, let's go orange. For fourths, I'm just going to split straight across and straight down again. So I get fourths. 1/4, 1/4, 1/4, 1/4. Okay, if I wanted a least common denominator, I would want pieces of a size big enough so that each of these pieces in this pie already can be created from the pieces that I cut it into. So let's look here. Go purple. So this looks more like an eighth, but I'm gonna split this into 3 pieces, and this into 3 pieces, and this into 3 pieces, and this into 3 pieces. And so there's that one there. So if I split this into 12ths, what I can do to get a half is I take 6 of the 12ths. So get the 12 pieces, I can get 6 of those 12s, gives me a half. So 12 is a common denominator with 1/2, right? If I take 4 of those pieces, I get a third, right? 1, 2, 3, 4 pieces, and I get a third. So I can get the thirds out of 12 as well. And if I only take 3 of those pieces, I get the fourth. 1, 2, 3. 3 of those 12 pieces would give me 1/4. So the idea is you have different sizes of pieces, but you make them, to get a common denominator, you cut them up finer and finer so that you can have a whole number of pieces that give you those larger pieces from the original fractions. So 1/12, or the 12th, is the size of the piece that I could take some number of those 12ths and turn them into halves, some number of those 12ths and turn them into thirds, some number of those 12ths and turn them into fourths. Okay. So that's how this common denominator stuff works with numbers. Let's do the exact same thing with some arithmetic now. So some algebra. Okay, so let's say I have 1 over x, I have 1 over y squared, and I have 1 over z cubed. Okay, so the idea was I was factoring the numbers out, right? We factored the numbers out, we got these different factors, and then I put them back together so that the end number was divisible by each of those 3 things. So here I want to do the same thing. I want to factor this out. It's already factored out, it's an x. This has y times y. That's already factored out. This is already factored out as z times z times z. So what I need for my least common multiple is I need an x, I need 2 y's, and I need 3 z's. So there's my least common multiple. It has the x, so that this divides into here evenly, y squared divides into here evenly, and z cubed divides into here evenly. So that's my least common multiple of those 3 things. Let's do another one. So let's go, say, x squared y. Let's go 1 over y squared z, and let's go 1 over z squared x. Okay, so I need each of these terms to divide into my least common multiple evenly. So I'm going to factor these out. I've got x squared y, I've got y squared z. They're already basically factored out for me. I'm just going to rewrite them again. Okay, so in my least common multiple, I'm going to need an x squared and a y so that this thing divides into here evenly. I need a y squared and a z, so I'm going to add an extra squared. I'm just going to make this bigger. If you make it bigger, then this number, this x squared y, still goes into here evenly, right? I've just multiplied by an extra y, so you still go into there evenly. And then I need a z so that this goes into there evenly as well. If I only had one y, this wouldn't divide into here evenly, right? I'd have y's in the denominator. And then this, I need a z squared and an x. I have an x, I've got two of them. I only needed one, so we're good there, but I need to make that a squared. So my least common multiple of those three things is x squared, y squared, z squared. Okay, one last one. Let's look at something like 1 over x plus 1 squared. Let's look at, say, x plus 1, x plus 2, and let's look at x plus 2 squared, x minus 1. Okay, so now I've got pieces that don't quite look like one thing, but since they're in a parentheses, the parentheses is treated kind of like just its own thing. I'm multiplying this times this. So my least common multiple, this is already factored, right? It's x plus 1 times x plus 1. So I need x plus 1 squared in my least common multiple, so that if I divide my least common multiple by this denominator, it goes in evenly. I have an x plus 1 already. I have two of them, so that bit goes into here already, but I need an x plus 2. If I put an x plus 2, this denominator divides this evenly because I don't have anything left over after I cancel, right? If I divide this, put this on the bottom, the x plus 1s stay on the top. There's still nothing in the bottom, so the division happened evenly. Okay. And then the last thing, I have an x plus 2 squared. I only have one here, so I'm going to make that a squared. And I have an x minus 1. I don't have any x minus 1, so to make that go into the least common multiple evenly, I have to include an x minus 1. So, do I have an x plus 1 squared? Yeah, I have an x plus 1 squared. Do I have an x plus 1 times an x plus 2? Yeah, there's x plus 1, there's x plus 2. Do I have an x plus 2 squared and an x minus 1? Yeah, there's my x plus 2 squared and my x minus 1. So this is my least common multiple for these three things. Okay, now that we have least common multiples, we're going to be able to do addition and subtraction much easier. We'll do that in the next video.